welcome to The Explainer. Today, we're jumping right into something huge, what's been called the deep learning tsunami. It's this incredible force that has totally reshaped our world by changing how machines understand language.
So, let me start by asking you a question. Just think about your day so far. How many times do you think you've used machine learning? Seriously, take a second. Whatever number you came up with, the real answer is probably way, way higher. It's become this constant, almost invisible presence in our lives. I mean, think about it. From the moment you wake up, maybe your smart speaker plays a song it thinks you'll like, to every single web search you type in, machine learning is there, working away in the background, trying to curate your world and, make things a little easier. There's this researcher, Pedro Domingos, who points out that a totally normal day for any of us is just packed with these things. But this isn't just about convenience, not at all. Machine learning, and specifically this field we're going to talk about called natural language processing, or just NLP for short, it's trying to solve a massive, very human problem. And that problem is information overload. And when I say massive, I am not kidding. Just look at this number. This is how many biomedical research papers have been published on just one database, PubMed, every single year since 2010. Over 1 million a year. No human team, I don't care how big, could possibly read and connect the dots on all of that. It's impossible. And this is the real danger. A researcher named Swanson pointed this out way back in 1986. He said, without NLP, all of this would remain undiscovered public knowledge. Just let that sink in. A critical insight, maybe a clue to fighting a disease like cancer, could be sitting right there in a published paper. But it's effectively lost in the noise because no one can find it. That's the problem NLP is trying to fix. Okay, so we've got this absolute flood of data. How in the world did we even start to get a handle on it? Well, the answer didn't just arrive, it hit like a force of nature. It was what one famous researcher called the deep learning tsunami. And the speed of this thing was just staggering. I mean, look at this chart. In 2012, fewer than 40% of the papers at the big NLP conferences were using deep learning, okay? Just 5 years later, that number skyrockets to 70%. It wasn't just another new tool in the toolbox. It became the toolbox.
Now, what's really interesting is that this whole deep learning revolution actually took longer to hit language than it did for, say, image recognition. And the reason why is pretty fundamental. For an AI, images start simple. They're just pixels. It learns to build those pixels into lines, then shapes, then objects. But language starts with words, and a single word like house is already overflowing with complex meaning. It's a much, much harder starting point.
So how do you even begin to teach a machine all of that rich, complex meaning?
Well, a huge breakthrough was this technique called word-to-vec. What it does, at its core, is it transforms words into numbers, into what are called vectors. And it does it in a way that lets the machine actually start to understand what the words mean. And how does it work? It's based on this beautiful, simple, but incredibly powerful idea from a linguist back in 1957 who said, "You shall know a word by the company it keeps." That's it. Word-to-vec basically learns what a word means by looking at all the other words that show up around it, over and over again in billions of sentences. But these early methods weren't perfect. They had one really big limitation. Take a word like bank. You could be talking about the Bank of London, a financial thing, or the Bank of the River, a geological thing. Word-to-vec would just create one single representation for bank, basically smushing both meanings together. It couldn't tell the difference based on context. Now, that limitation actually brings up a really important point. To really get what's going on, we need to zoom out for a second and put deep learning in context. Because even though it's the big thing right now, it's definitely not the only game in town. That same researcher, Pedro Domingos, came up with this really great way of thinking about it. He groups machine learning into 5 tribes. You've got symbolists who care about logic, Bayesians who use probability, and a few others. The stuff we're talking about today, deep learning, that all belongs to the connectionist tribe. And their whole philosophy is inspired by the human brain, this idea of building complex networks of artificial neurons. Okay, so now it's time for a really crucial reality check. Because for all of its incredible, world-changing power, deep learning is far from perfect. It has some really significant and sometimes pretty dangerous blind spots. First off, there's the black box problem. These systems are often totally opaque. We can see the input and we can see the output, but we often have no idea what the model has actually learned on the inside. And that's dangerous, because serious bugs or scary biases can hide deep inside that network, and we might only find out about them after the system is out in the real world.
Second, these systems are what we call brittle. This means they're really bad at adapting to new situations they weren't specifically trained on. So imagine a self-driving car. It's seen millions of miles of normal traffic. But what happens the first time it sees something totally weird, like a fire truck stopped sideways across the highway? It can fail, and that failure can be catastrophic.
And finally, and this one is just wild, deep learning systems have absolutely zero common sense. There's a famous example where an AI classified a photo of an overturned school bus in the snow as a snowplow. Why? Because it learned an association between big yellow things and snow and plows, but it lacks the basic toddler-level common sense to know that a bus is still a bus, even when it's upside down. So here's what it all comes down to. Deep learning is an unbelievably powerful tool, no question. It's helping us make sense of our world in ways we never ever could before. But it is also a deeply flawed tool. It's opaque, it's brittle, and it has no common sense. And that leaves us with a really big question we all have to grapple with. How do we best use these incredible tools and all the good they can do without being fooled by their profound limitations?